Hey folks, Mr. Dell here. We are talking about lines. So when you graph lines and whether all lines have intersection points or not. So I'm going to talk through this. I'm taking this problem specifically this is from CPM, and this is course 3. This is section 5.1.2 and number 519. So it says Fisher thinks that any two lines must have a point of intersection, meaning they cross through each other. Is he correct? If so, explain how you know. If not, produce a counterexample and explain your reasoning. In this case, a counterexample would be an example of two lines that do not have a point of intersection. So if we think when we're graphing, and I'm just going to do little drawings here to see. So here's our X and Y axes, right? And so if we're graphing and we've got a few lines, right? So this one passes through that y-intercept and has a negative slope or a decreasing growth rate. Okay, and then this one here passes down here at that y-intercept and crosses up like so and has an increasing growth rate, right? So that's an example of a line, excuse me, that does intersect. And really, a lot of lines do intersect. There's a good amount of lines that would intersect. But is there examples that don't intersect? And yeah, what would that be? Well, in that case, you would have a line, and I'm going to just draw my quick little X and Y axes. So a counterexample here would be a line that would maybe have crossed through at, say, 2 and increase at a rate of 1, right? It goes over 1, up 1, over 1, up 1. So this would be y is equal to x plus 2, correct? So that would be that line. Well, if I gave you the equation y equals x minus 4, how do you graph that? Graphing that would be down here at negative 4 is where the y-intercept would be. And it would also increase at a rate of 1 over 1, right? Up 1 over 1, every 1 over, it goes up 1. That's its growth. So what's going to happen? Those two lines will never cross because they have the exact same growth rate and they started at different places. So that's our counterexample, is graphs that have the exact same growth rate and different y-intercepts are parallel lines is what we call those, okay? So our counterexample are, so parallel lines never intersect. And in order to be parallel lines need to have what? So parallel lines need to have the same slope or growth rate, but we would say different y-intercepts, right? That's how you would know it's a parallel line. Same growth rate, different y-intercept. Okay? All right, there we go.